Hi, welcome to 3Rail Steve, and in this video we'll be making some 3Rail track. I thought today I'd get into how I make 3Rail track. So this is a piece that I've made a little while ago. I thought I'd just go over the key points of the track. So you have these outer rails, the fixed rails, which are called stock rails. So that's the curved one, and this is the straight one. Then you have some check rails, which obviously keep the vehicle in the correct line as it travels through the points. And you have the frog, this sort of V shape, which basically splits the two lines. And then as you travel through the point, you have these rails, they're called wing rails. And these travel down to the actual point blades that move, if you can see that. So how to make it? Well, first of all you need a template, and I get these templates from a computer program called Templot. So I just print them out onto bits of paper. Now you can basically make a whole layer of templates on Templot, but for this example I'm just concentrating on this one section of track, which is just this one point. So yeah, so we have the template, and we have some 2mm cork which I've spray mounted to it. Now if we just get into the track, this is the track. So this has been cut from this Pico Rail Flexi track. And it's just a case kind of making the actual pieces of rail to fit the template, and shaping them to also take into account things to do with the blades and the way the point operates, but I'll get a bit more into that later. So yeah, so we just quickly show you sort of roughly how I do it. I've just got some track here. So if I just find some snippers, you can just basically chop the track. So it's quite hard, but you can do it. Like that. Always got to just wear glasses because bits can sort of fly off. And also, if I just show you as well, find another piece of track from somewhere. You can shape the track, or shave bits off of it, by using one of these. So if I just, and really if you just, you can make some quite nice, you can actually so it's also extremely useful for grinding the ends down of the track, and this makes sliding the plastic sleepers on and sliding joiners on much easier. So basically remove any imperfections. Like that. Then it's just a question of once you've cut all the pieces out, you've shaped them to the desired shape, then it's just a question of actually sort of stringing them together. So just a quick example, so you just thread these plastic sleepers back on. So because once you stripped the bit of rail that you need for your project, then you're left with these, and they're really useful things actually, because not only do they act as sleepers, of course when you put them back on again, they made sure all the gauging is correct. So that is very useful. So looking at this template, I'll show what I've done already. Screwdriver now. Right, so I've basically glued these copper strips. You can buy copper or brass strip on eBay, and if you just make sure the size is similar to the sort of the profile of the set track sleepers, then and you don't have a problem with the height. The height is going to be sort of kind of the same, which is fairly crucial. So yeah, cut them up again using these, and basically glue them to your template, and then you can make a start. Now I always start with the frog, so I've already soldered this item on here, and the thing about the frog is it kind of determines the whole geometry of how it's going to turn out. That frog, everything basically sort of works away from there, so that the angle of the frog determines how the geometry of the point, if you like. And you can kind of see that when we fit this piece on, which we're about to do. I'm going to thread this through these sleepers. Just can be a little bit tricky sometimes. So let's get rid of that bit of wood, don't need that now. So, make that easier. So just pop them through, just get the general idea. The thing is, you just got to be a bit patient and not force them through, but just slowly slide them through. And it's quite handy having this flexible base, and it just helps you ease them into position, because you can sort of curve the base away from it. You've just got to be gentle with the sleepers because they are quite delicate. So now the job is to, so you threaded all this together, sort of kind of in the pattern it's supposed to be, and then you just need to push it very carefully. Now, bending these sleepers around too much until it all lines up. So that looks good. So you now end up with that. And the other key thing to bear in mind is the actual pattern of the sleepers. Now, if we go back to the explanation at the beginning about the types of rail, you have your stock rail. Now this is the curved stock rail. Now the wing rail, which is this one, has to be in gauge with the curved ring rail has to be engaged with the curved stock rail. So these sleepers are joined up so that it keeps it all engaged. So I normally just do a pattern where I sort of alternate the sleepers. So again, looking at it from the other side, you've got a straight stock rail, a straightish stock rail, and a straight wing rail. And again, these sleepers are the ones that determine the exact gauge. We know the gauge is correct because it's set track, it's not going to be wrong. The other thing to make sure is that the sleepers always come out at 90 degrees to the track, and then that way we know that it's all going to be in gauge. Okay. Now you might think it looks a bit of a mess with sleepers going everywhere, but if we look back at this piece of track, with 3 rail there's a lot going on. you've got all the sleepers. You're going to ballast it for one thing, and paint the sleepers as well brown. And by the time you stuck the third rail on the top, which are these bits here, really it's quite difficult to see. If I just look down the track there, it just looks like a piece of track. So look at it like that. And I'll show another one that's a bit better ballasted, which has some quite interesting piece of track. This one, it's got some terrible soldering on this, and I'll go into why it's terrible. I ran out of my solder, and I just used some solder I got from the shop, but I normally use this stuff. It's called it's made by DCC Concepts, and it's like the best solder I've ever used. It flows nicely, it melts properly. If you just use ordinary electrical solder, you end up with results that look like that, which is very suboptimal. In fact, I will be melting all that off and redoing it again because it just looks terrible. Okay, so kind of explained all that. So we're at the point really where we can start soldering all these bits of rail to these metal sleepers, and that's kind of what gives the strength to the point on the layout that will hold it all together. These plastic sleepers obviously give it some strength, and also where the points actually move here, you want something underneath that's nice and smooth, so they move really easily. The other thing to bear in mind is we're not talking about normal 2-rail. If you were doing normal 2-rail, this setup would never work because it would just be, you would just have an instant short circuit between the two sides of the rail because you've got a complete piece of metal going across the middle of it. But in 3-rail, that's desirable. We want these two bits to be electrically connected and the same polarity. Now, one downside with 3-rail is this. Here's a 3-rail vehicle, or a bit of one. These are the bits that pick up from the middle rail. These little spoons or shoes. So you can see a slight problem. As the little vehicle goes across, it's going to cross the wing rail. Now, if you think about it, if that wing rail, very hard to say wing rail, if that wing rail is live and has the same polarity as that and that one, then you're just going to get a short circuit. So this section has to be isolated. So I use isolating rail joiners. So these little things. So I don't know if you can pick it up on that camera, but that's what you do. And you have the added benefit that when you connect this up to an electric motor, the point blades move nice and easily because they're not connected to another piece of metal. They're connected by plastic, so they don't have that same kind of level of springiness in them, which makes it quite hard for a solenoid motor or whatever type of motor you're using to move it and actually stop. Motors sometimes have a tendency to try and keep pushing against the blade, certain types of motors anyway, and it's not very good for them really. You want the blade to just stop at the point you want it to stop at and then require no more power. Now I've just noticed something actually which is interesting. So this point blade needs to actually sit in that groove, so I'm just going to move that along a little bit. And similarly, that one is a little bit far over, so I'm going to push that one in. I have actually got some marker pen marks on the track where I actually cut the grooves originally. So if we just look at that track, you can see, oops, my hand's a bit shaky, but just going to bit of focus on that. You can see, kind of see where I've just cut into that bit of stock rail to create a recess for the track blades to sit in. And probably if I just come down on it like that, you can probably see it. And if you also look at the blades, you can also see that they have been filed down into basically sort of sharp, well, blades, which is what they're called. So that kind of helps it all to work properly. So when the vehicle runs through the points, it actually it doesn't derail. So okay. So it's not going to work. Right. Okay. Right. So as a test, got this tender, which is actually one of my worst bits of rolling stock. It's from a very expensive locomotive, but the actual its ability to go through points and things is not amazing. So I'll just quickly test. Oops. Hopefully it's actually on the track properly. If that is going to work. Now obviously when I solder this in, I can actually get all this stuff to line up better than it is at the moment. That doesn't feel too bad to me. We'll just go the other way. Obviously that kind of needs to be more there. We'll just do that again. But yeah, that's looking reasonably okay. Yeah. So, and the other thing is, see if it actually go in that direction. It's always good to check things to see if they actually work before you carry on soldering them. That's quite tricky to do, but that seems fine. So yeah, that's all good. We're in pretty much at the position where we can start soldering it up. Thank you for watching the video. Hope it was informative, and I will see you on the next one.